SAFE Software is pleased to present the 2009 FME International User Conference. This session is presented by Michael Lear, the Assistant GIS Project Manager and Technical Lead for the Washington Transportation Framework for GIS. Michael's project work is extensive, having worked on Y2K mitigation, the Unstable Slope Management System for the Washington State Department of Transportation, and the Post-Traumatic Stress Disorder Management application for the Department of Veteran Affairs.
Our project is involved in getting transportation data from various sources, the best sources possible, and all different types of transportation data, and trying to put it into a seamless, connected data set. I'm going to be talking about how FME is being used in the server side and workspaces to facilitate this. And in the user interfaces, we have data portals that also leverage the FME processes. The transportation layer is supposed to be the best data available from all possible sources. It's seamless, connected, consistent data between all jurisdictions, and this way we have a complete statewide data set. But it's not all about data. It's about processes. It's about agreement. It's about collaboration between different jurisdictions. It's a big part of the thing. So when we talk about the data, we're also talking about the process, the software, the infrastructure, everything that's necessary to make that work. So what we're trying to do is we're trying to get every one of the counties in the state of Washington to give us data, to be able to connect that data, and to be able to put different data from different jurisdictions into the same data set, or maybe multiple providers from the same jurisdiction. Conflate that data so we have a complete data set for the state of Washington, and then maybe submit this data to the national map. We've already submitted some data to the national map, and there's a thing called Transportation for the Nation when they're trying to get the whole national map together. We have several different states that are partnering with us. We have 6 different states: Ohio, Tennessee, California, Oregon, Idaho, Washington, Nebraska, and we're all trying to work for the same purpose. So what we're trying to do is I've got this kind of divided into 3 different processes just for this discussion. Within these processes, there's multiple processes, and we could go into that. I'd give 4-hour workshops on this kind of stuff. The first one is kind of loading the data. What is the provider? Who's the best provider of the data? Is there multiple providers for that data? Once we find that out, we could build a translator specifically for that provider using an FME workspace, and then they can submit that data through a data provider portal, which leverages FME Server, and then we have change detection processes. The middle part is after the change detection, we manage those changes, and then we start integrating this data to make sure it's seamless, connected. We have attribution applied to a core set of segments. So when we pull this data out for E911 purposes, they will have all the attribution necessary to manage geocoding or planning with LRS data. Last part is how do data users get this data? We have this data in a centralized database, but they need to get this out. So we have a data user portal, which again leverages the FME server to help get this data out in any format they want, in any projection they want. The idea to get it out into their systems, they can use it. We're also working on data products that are specific for a specific need. The E911 people have a lot of different needs in planning, which is LRS data or something like that. The incident location people have different, HPMS people have different needs. So we're trying to build these different products. So this is what we're doing for our research. This is the architecture, 2 different servers. Now, we're trying to get this into more servers when we go live. But right now, we're sitting there with the research. We have a database server. We have an application tier and the web tier are all on one server. We use Latitude Geographic Essentials as the interface. We use FME Server to serve up this stuff and the FME workspaces to create the translations. Why translate the data? We try to automate processes. We're trying to make this maintainable over time. We're trying to have temporal data so we can have, well, what was it like in 2008? What was it like in 2009? To do this and to run a lot of automated processes, we need to standardize this. You can't just go, well, this is shape file, this is geomedia file, this is a coverage file, this is whatever it is, map info, which we're getting all of these things. We need to standardize it so then we can start running processes and reports. And we want this data to be retrieved by different people, used over and over again for different needs. So we need a standardized database. And here's an example of, this is when I talked about the 3 different tiers. I'm going to go over this in a little bit detail if I can get this mouse to work. The mouse doesn't work. So what I've got here is the data provider. We get this is the initiation process I talked about. And as soon as we get that taken care of, we have a transform and load process. This is where we take the workspaces and get these to work. And once these are done, the data provider can submit the data through the data user portal, or data provider portal. It goes into the loading database. This is a simplified database. Amazing this doesn't work. This is a simplified database. This is not as complicated as the other databases. But it gets the data in the loading database, standardizes. Then we can start running the QA/QC processes, the data provider reports. Is that the reason?
I don't know.
There we go. So we can have data provider reports. And the idea here is that we're not going to be the judge of their data. We can give them reports and saying, well, we have overlapping address ranges. We have gaps in their LRS. We have 1-foot segments. There may be business needs for that. We don't know what they are, but a 1-foot segment seems kind of odd to me. So we can give it to them and let them change their data if they need to. Then we run change detection and change management, runs it into the staging database, which is where we do all our legwork. This is where we do the QA/QC, we do all the integration, we do the edge matching at boundaries so we have a seamless connected data set. This is where we apply maybe somebody else's line work that's a little bit better than the line work from the local providers, and all this kind of stuff, and get it ready, put it to the production database, the user database, where we have a data user portal, and the data users can come in, take a look at the data, see what they want, select the data either by providers or by data product or by polygons, and then choose what kind of way to get the data out through some sort of transformation, the transformation process with the FME. And it pulls it out in their format, in their projection, and it says FTP, but the FME server actually just sends them an email, says your data's ready, here's where you come and get it, and you can download it. All underneath we have control processes that manage this stuff. So the data provider portal, this is they know who you are, you're a qualified provider, the person that's submitting is a qualified provider. I happen to be a qualified provider for Franklin County. They are They are authorized to submit road data. We can have multimodal data like ferry data, light rail. Right now we're going for the low-hanging fruit, which is road data. They go to wherever they are on the machine, get the file that they're supposed to upload, click the next button, submit it, thank you very much. They send a message. This application sends a message to FME Server, which then goes, oh, that is the transformation I need to use. This is all database driven. Fires off the transformation process, loads the data in the database for us. As far as the user is concerned, they've given us the data. So the transformation process, and I'm going to people who have done FME kind of know a lot of this stuff, but you read the source data clearly. But when you have a centralized database, you need to alter that data to meet the standardization you're going to have in your own database. When I say alter the data, we do not try to alter the meaning. Every time I create a transformation for somebody, I send it back to them and said, is this your data? Have I changed anything meaningful? And I've changed the attribute names. And maybe the data type, maybe something like that. But it comes back out, it's their data. And then I have to add attribution that is required to make that database work. And a relational database in the SDE, we use our SDE. And then I have to map the resources. I have to map their attributes to the attributes that are standard in our database. And now it's sitting in the database. Now here is a true blue, very simple transformation that actually transforms Franklin County data. Now I have to have source data. and I have to have destination data. We all know this stuff. This is all FME processes in an FME workspace. This is a template. All I have to do is change certain things in here. The rest of it works for me. In this case, in the upper, this one here is the source data. I add the source data, whatever it is. It could be in this case, it's a GeoMedia warehouse database. I don't know, it's not a shapefile, it's a GeoMedia warehouse. This one right here, I'm reading my own database. I'm reading my own database, getting an attribute and then adding to it, so I have an ID that I have to add to every record. So I'm actually reading my own database. The next process, this is where I have to manipulate things. They may have their own city codes, and they may have a way that they manipulate their address data that I have to adjust because that's the way they do business. So I have to adjust things like that. And this is where really the work is in this area right here. And that's really the only place that you make a lot of changes. And here's where you do the mapping. And this is, we use schema mapper, so you can do the schema mapping in a CSV file. I attended a presentation by Mark Stokes, and there's a lot of data validation. I will be changing this workspace to allow for much more data valuation, and I will be putting that up here right at this point right there before I even send the data through, is do some data validation. And so it's pretty cool what he showed. So here's the 4 custom transformers we use, never change. This is the one right here that does a lot of things like we use GUIDs, UUIDs for all of our IDs, so I have to create all those. I have to go in there and I look at their ID, the data provider ID. These are things that are all standard that have to happen, and I put them into variables that get applied to every record as it goes through the process. I also round some attributes, LRS data, things like that, so that it meets our data types. And I keep forgetting to do this. This is kind of what I do. I just said I'd talk to you about all these things. Here's the one that reads and writes to the database. What I have to do is I have to read my own record, then I have to create another record for this one lookup table, write it to the database, and then I put that value into a variable that gets passed to every record in the database. So it's called a reference data set. So I know that data set in there is this reference data set. I can always get back to the original data set as I progress through my conflation processes. Our problem is tracking this data as we start messing with it in the conflation process, moving data to match at boundaries and stuff like that. Here's basically a glorified record separator. Part of the process is I want to get the attributes separated from the geometry. Because I put them in the database differently. They're tabular data, all the attributes, and only the geometry is spatial. And in FME, it's the SQL writers are a lot faster. And then I have to make sure that I write some of the stuff before I write the others, because I have a relational database, and some tables have to be written before others. So this kind of separates that out for me. So basically what I'm trying to do is we have King County, which is an Esri geodatabase, SDE geodatabase. This Pierce County, which is a coverage file. They send me the data. I put it in the database. I have 2 spatial tables in this whole database. One's line work, segment geometry, and the other is my reference points, which are the point geometry. Everything else is tabular. And I can get this exact same data back out. Indistinguishable except for the attribute names. Change detection. Now we talked about the data provider portal. I do a little bit upfront validation to make sure it's the right file they sent me. And I read the source data and retrieve it. We go through that transformation process, and then I fire off some change detection. This is where we use FME again for change detection. What we do is we have the FME perform geometry comparison. We have either identical geometry or we don't. If it's not identical, there's been some change. I go through attribute changes with SQL Server, T-SQL stuff. Are there attribute changes, yes or no? As we go through this process, we flag each one of these records as changed, as not changed. There's missing records. That means that I compare what they're just sending me with what I received the last time they sent me, and there's records missing, which means they've deleted them or somehow altered them so they don't exist anymore. We call those missing records. And then there's new records. And there's a lot of reasons why that would happen. So all this gets flagged. And then everything that's identical, everything that hasn't changed at all, I don't care anymore. I just want to deal with what's changed, not with what's identical. And that way I don't have to deal with as many records. I mean 50,000, 100,000, 200,000 records, and I deal with 50. That's a lot easier if I have to go and manage that kind of stuff. Here again, I forgot my little thingies. What we can do at this point is, like I talked about the QA/QC reports, we have a connectivity report which goes in and says, are you connected everywhere? We have one county that has 16 different networks. We had 16 different networks, and in those networks there's 5 islands, which sounds good, and then one big network. Well, all the other networks were little subdivisions that were foot off. They weren't connected. So we run a connectivity report, and people are ecstatic about this report because it's just digitizing issues. Somebody went in and just made a mistake. So in this process here, here's where FME takes a big role right here. I transform it in. FME does the geometry comparison. I promote changes to the database. And in all this process, I'm using FME to transfer data, and then I clear the loading database. I don't want this data in the loading database anymore. Now I have a copy of it in the staging database, the copy that I'm going to use for the next time I do the change comparison. Really quickly, we have a segment, and we have primary segments, and so we go through the process to say which segments are the best segments to use, and then we apply attribution from whatever other source we're getting to those segments. And it's called an MLRS, Multiple Linear Referencing System, but you can use it for address descriptions, stuff like that. We don't throw away the other segmentation, but it is only maintained in their geometry. So we have multiple geometries for every segment, every set of segments. But the segments are the datum that everything applies to. The data user portal, I'd love to demonstrate it if I'd had more time. But there's the data user portal. And this is a cached map service, an Esri cache map service. We tried to do it dynamic, but it takes too long for the data to load. And so this cache map service, it does just fine. You can drill down, and you can get data. You can also, there's where the toolbar is. There's an extract. I'll show you that in a second. You can also, in this tool, this is the Latitude Geographics GeoCortex Essentials sitting on the Esri ADF. You can actually go in there and select features. You can select groups of features, and you can obtain summary reports. You can download it to CVS if you want to, a CVS file or CSV file. We use CVS as change management in our. And here's the extract. You click the extract button, and right now we build an iterative process. We want to have special downloads for certain people. We want to have that stuff. We're not putting that in yet. We're just trying to get the basic stuff down. So right now you can select by county boundary or data provider. You can select by previously defined custom extract, or you can select by polygon at certain levels. We don't want to pick polygon at the whole statewide level. That's a whole lot of data. It takes a lot of time on the server. So at certain levels they can go by polygon. If you've already gone through a whole process of choosing data, like I've gone through and I've drilled down and I've got exactly what I want, you can save that as a custom extract, and you can select this button and then go into your custom extract and say, I want this because I get this all the time, and this is what I've already chosen before. And then you can pick your file type, and this goes right to the FME server and says, here's the file types I have available to me. Here's the projections I have available to me. In our case in Washington, I limit those projections to what is available for Washington. And then it's submitted to you've submitted to the FME server the request, and GeoCortex Essentials is done. This is the message you get from FME server. We're using Spatial Direct right now. And they send you an email and say, here's your file, come and get it. It's only available for an hour or so. So what I've covered is I've covered the data provider, how the FME works with the data provider, how we get data in to the portal using the FME processes, big combination of the workspaces with FME knowing what the workspace is in. This is data-driven, so we have a data-driven process where that FME workspace is applied to a provider for a particular type of mode. The database knows that, goes and reads that. FME Server does that. Talked about, that's the workspace. Talked about the change detection where we use FME to help change detect. There's a lot of stuff I didn't talk about with the FME in here. We're doing a lot of things like which segment is a coincident with this segment, on and on like that. We're doing a lot of stuff with FME Server or FME with trying to do conflation and how do we do that. And then I talked about how you retrieve data through using FME Server with a internet portal. God, did I get that in 20 minutes?
You did.
Whew, that's a first. Any questions?